no translucent inputs in order to get the better results. So there is in the market and now a system. And then in the lab we proceed. So I want to talk to you a little bit today about some problems in digital dentistry, which exist in any workflow, and I will pick a specific one. Obviously, there's more, but I want to talk about the dark substrates, managing the dark substrates. Now, before I go into that, I really want to put a little bit of context, just to show you in a few lines how we work, what is our workflow, because as you well know, there's 55,000 ways to work. So just to put things into context, I will make a small comparison to understand our way of thinking with architecture, which has always been a huge inspiration for me in terms of thinking, planning, treatment planning, etc. You know, the whole thing with thinking with the end in mind, I think nobody does it better than architects. And I think there's a lot to learn. And if we are to talk about the process of how an architect does it, if you have like a simple project, and here I just made a parallel between a project of my two boys' room. My wife is an architect, by the way, so she made the small project I'm going to make a parallel with, and what we do as dentists. So what they normally do in architecture, first they start with data, okay? So, which means pictures, measurements, you know, the basic things. And for us, the same thing happens in a consultation, where we see the patient and we get a number of files and file formats that will give us the information required for planning. For example, on portraits, we have the relationship with the face. On CBCT, we see the bone availability. On scans is the canvas on which we plan. On videos, we see the lip position and all of these things. So the second you have the data, in architecture, you always start with a 2D plan. Now, why is that? Because these people are the best in 3D. However, they always start in 2D. And they have all the softwares. I mean, everything we have as advanced software in dentistry is somehow imported and inspired by either architecture or engineering. But the process doesn't matter if it's on a software or on a piece of paper, always starts 2D. Because to put it simple, it's systematic thinking. And if you want to think about it, every 3D file we see in dental, we see it on a computer screen, which is also 2D. So it's a bit different what we do, because we interpret 3D information in 2D images. So after you have the 2D plan in architecture, then you have to scale it to 3D. So you first fix 2 axes out of 3, then you scale it up. And a huge part of, for example, interior design, which is the example I'm giving, is the use of libraries. Library means there's an object that exists as a file and also in reality, so you can buy it, and the one from the library use it to make the project. And once the client accepts, you can go to the store and buy the actual object. So it makes things very predictable. Now, once you finish all of this, you render this. So you make like computer generated imagery, like the one you see here, of how the project will look at the end. I need to see this image instead of this image, for example, to understand what's it gonna look like. Now, in terms of dental, if you think about it, libraries for me are at the center, at the core of digital dentistry, because if you think about PROS, we use libraries of teeth, which is like predefined chunks of information that speed up the process. if you think about guided surgery, you need libraries of components, otherwise it would not be possible. Libraries of brackets for ortho, etc. So libraries at the core of it. Now, in prosthetics, design is these two things. You need to select the library and you need to position the library. Now, the selection is generally done in 2D and the positioning is done in 3D in a CAD software. This is how we do it today. So in 2D, we use SmileCloud, the technology which we were involved in developing it, where this works as a library search engine, where you can search in real time for certain parameters specific to the case of a library you're going to use. You can also render it in real time. And then once you select something and what the patient
Florin,
also can see and choose. Yes?
Florin, sorry. You can
Yes.
get closer to the microphone, please.
Yeah, this is the microphone.
More? Oh, okay.
Yeah, like this?
It's closer?
It's okay?
Please. I think yes. Thank you so much.
Mm-hmm. So once we select the library, then the positioning of the library will finalize the design, and you position it according to what? To biology, to functional envelope, to phase, all of the principles that we know. You functionalize the library by positioning it, basically. Now, of course, you can functionalize the library by changing the library, but that is not really predictable, and we try to avoid that by altering it. So in terms of the 2D, here's how it works. This is an example like from the technology we use from SmileCloud, where you can just input the parameters what you want in terms of design. You can change the lines, the smile curve, the zenith curve, the proportions, papilla points, all these things. And you search in real time for libraries from a huge database that fit in your search criteria. And you can see them in real time. Now, this is hugely beneficial because you can do this in real time with the patient. And all of the options are viable options in terms of the final ceramics. And also you can just do like a quick preview for the patient to understand. So you're somehow reversing the process. Normally you have like an entire process to get here, because you need to print, you need to do the whole design, print the model, etc. And it's a liability. You can waste time, resources, everything. The way we do it is we select the library, agree on the patient, and then we start the process, so we don't waste resources and time. Now, this library at this moment, they are very, very cheap, and in I think 1 or 2 weeks from now, they will be completely free. So it's really nice because you can just choose one, download it, and then you go to 3D and you're positioning again with according to the principles you decided. Okay, you end up with a 3D model that you can print and you can transfer to the physical reality. So the patient can see like the traditional mock-up. Now, if the case is additive, it's worth to do this. If the case is reductive, you don't even need to go through this step. Then clinically, you need to do everything according to what you plan. So you need to recontour the tissue, prep the teeth according to these things, and then you can be very predictable in milling monolithic restorations that you can copy the shape, exactly what you chose, staining it a little bit, and we know already that this can be very predictable. You can see the design in PM in bisacryl on one side and on ceramics on the other. And this works very well in ideal scenario. Now, what you saw is the happy path. Happy path means what happens when everything goes perfect, okay? And this is, a very small part of the reality, because in reality we have multiple problems that we have to deal with, and I will just pick one for today. And this is when we have like dark teeth, for example, because when we have beautiful substrate, monolithic works very nice. We know this very well. It's not difficult to achieve nice results. However, whenever you have dark teeth or dark roots, there is a problem, because when you work in monolithic, you don't have the optical tool set from layering. So you will be much more vulnerable to this problem than in analog. And there are three ways you can overcome this problem. So again, remember that one way can, again, depend on the technician, and this is by staining the ceramics. So let's say we have a case like this, and here you can see we have a lateral that is dark when we will remove this composite. First, like in every single case, we do design, we print it, we try it in, then we crown lengthen according to it, we prep according to it, and you see we have a dark lateral. Now, if we just do the normal stuff, obviously this lateral will have a different color than the rest. Now it's very important to understand how color is what is gonna result from. So let's say we take a shade of a monolithic block, doesn't matter multi-layer or not, and we are gonna mill that lateral. The final color will be a couple of things. Will be the shade you choose, factored by the thickness. So for example, if you take like a B1 block and it's 0.5, it's gonna be B1. If you take a B1 block and it's 1 millimeter, it's gonna look like a BL. So thickness is very important. Second, it's factored by how dark the substrate is. That also impacts the color. It's factored minorly by the cement you use, which you don't really want to mess with around too much because it's not predictable. Is factored by the stain, by what you paint on the surface of the ceramics, and at the end also with the dark inside of the mouth. So all of these things come with the color at the end. So one way to do it when the color is not so severe, when you have like a mild discoloration like in this case, is generally speaking, you prep slightly more. You don't have to prep a lot more. And here, what you can do is you can stain inside or outside of the restoration. And here's an example. You can see that the veneers have different thicknesses, so they are stained differently. Now, the best guy in the world to describe this and to teach this is for sure Paolo Cano, who has its technique of multiple layers and multiple stains. But just to put it simple, in this type of case, you can stain outside of the restoration, and in this case, because the restoration is more thick, you need to add chroma to it, because otherwise it's going to be more white than the other teeth. And also to block the dark coming from the substrate, you stain it inside to block the color. When you stain inside, the stains are metal oxides, so technically speaking, you will lose adhesion. However, if you glaze on top of that, you regain adhesion, which means when you design this type of restoration and you know you're going to stain inside, you should increase the cement gap, not the margin gap, but the cement gap of the restoration. Otherwise, you'll have trouble adapting them. So in this case, we stain, and also you can see here, the critical area in this type of cases is at the margin level. The margin here, you want to place it subgingivally, and then also think about augmenting the tissue a little bit. Otherwise, you're always going to have like a gray halo. So we bond the stain restoration, we augment with a soft tissue graft, and then this is the result at the end, and this is in polarized light. Now this works fine, however, it's technician dependent. So if you depend on like analog technician to layer in a nice way. It's just the same, but more difficult because staining has less of a tools than a guy that does layering has. So you don't really get away from the requirement of the technician being highly artistically skilled. Now, another option here is coping. This is easier for the dentist because the dentist just has to prep more. So here we have two laterals, and in these two laterals we're going to prep more, and we're going to make, like, we're going to mill a crown and coping. And you can see how it looks. The coping, you can make it Emax, you can make it zirconia, and they're going to be bonded together in the lab. Okay, and then you receive one crown that will block. Now, the advantages of this technique is you can, technically speaking, block any color. So it doesn't matter if the tooth is black, for example, like in this case. It's easy for the dentist, just needs to prep more. What are the disadvantages? It's expensive. Technically speaking, the technician has to make two restorations. It's time consuming because many times you cannot make them both in one CAD design. If the space is thin, you need to make the coping first and then the technician makes like manually a thin chamfer there and rescans. I'm talking about if you want to get very good precision. Another disadvantage is you have two interfaces of cement, so it's also technically sensitive. But again, it is an option. So in this type of case where you have dark teeth, you have, for example, here zirconia. Actually, I don't remember in this case if it's zirconia or Emax, but either way, it's stained to get more chroma because otherwise you will have a problem blocking the white. Then you have the ceramic crown on top, and then you can block it very nicely. Now, the last part I want to tell you, like a very nice technique, is one that we're also going to publish next year in QDT 2021. And this is something we have been doing lately. And since we do this, we rarely do the other two. I mean, the staining you still have to do in many situations, but the coping I kind of like discarded, let's say, to this one. Here's an example again where we have dark teeth and dark roots. And like in every case, you do a design first. And to show the patient the modifications of the design, you put the mock-up on top, and then you're going to paint with the black marker the areas that you're going to reduce. And then I take like a pink composite, and I also mask the areas of the gingiva, because otherwise when you do the mock-up, it's going to be an ugly high contrast area with the bisacryl, and it doesn't look nice. And not only that, but that's exactly what we plan to do. So the pink that I put here will be substituted by soft tissue augmentation in those areas. So here again, once the patient accepts, we can go and cut the area that we painted with black, and then we crown lengthen according to the tissue. And then we restore the biologic width. We use a flapless technique here with an ultrasonic tip. Again, credits to Maestro Paolo Cano for this technique. It's amazing, simple, and very efficient wherever there's thin bone. And in our part of the world, most patients do not have a lot of buccal bone. We check that everything's okay. I always want to check with a silicone key according to the final design that I have, the length that I planned for and all this. And then I remove the old restorations, and this is what we have under. So this is quite challenging because you need to block both the substrate and the roots. So what I did here is I prepped actually here I prepped like a double chamfer. So one chamfer where I want the restoration to start, And a second chamfer is more incisively, like roughly 2 millimeters to preserve the ferrule effect. So just not to damage the structure of this already damaged teeth too much. And then I scan this and I provisionalize, the patient goes home. And then this is very nice. I ask our technicians, and this is what we do a lot now. So imagine just as they would make the provisionals today, they can make the provisionals in a transparent PMMA, right? You just put a transparent PMMA instead of the normal PMMA and you have your final design. But in the inside of this, you can design your ideal abutment, okay? Which means it's gonna be like coping, but inside is the ideal abutment that guarantees like uniform thickness for the final ceramics. And it has also like a cylinder for the material to flow out. This has amazing fit, and you can also do at the same time, you can do the transparent one and also the provisional. So you can do this before you're gonna do the procedure and finish in one session. And then when I get this, I'm gonna sandblast, etch, silane, the bonding process. Then I take like an opaquer. I found something from the lab, resin based. I block the metal, and then I fill in the scopings inside with the like warm opaque composite, like dentin composite, and you just put it in on the chamfer and you cure. Then when you cut this, because you're not going to be able to remove, when you cut this off, you're going to have like a beautiful abutment according to your final design, which otherwise for me with my hands is a lot more difficult to do freehand, because you build it up, then you have bubbles, then you add, you remove. It's not easy. And you can see this is what I want ideally according to my final design. This is the silicone guide for my finals. And then you can see I only solved part of the problem, because I was able to block the centrals, but the laterals still in the area of ferrule, I still have like dark. And here in this area, we plan to stain inside. Here's a little bit more stain put just to show on the slide better, but you have to put a little bit just in that cervical area. And then you do the trying, okay? When everything's okay, and this is the day you're gonna bond, and this case I did with Gustavo and Marcelo Giordani. And we always do like this. At the day of the bonding, we do the trying. Then they are gonna take like the soft tissue grafts, and they are gonna create the tunnel, the pouches, place the soft tissue grafts, and just place the stabilizing sutures of the grafts. Then the second they do this, I take the rubber dam, isolate everything. I can bond. I can clean the cement very well. And the last thing they do, they come and they put like a composite in the contact area and put the final sutures to bring the tissue down. So this is how we solve also the dark of the tissue. So this is how it looks after healing. This is another view from the sides, and this is in polarized light. So I just want to make like a short overview of the tools you have when you go monolithic and you don't have the option to layer. This is how you manage color. These are 3 options. Probably there's more, but for me, these 3 are probably the most common sense and the best ones to manage almost every scenario. So I think that's about it. I hope I was okay with time.